Today, we're dealing with the ultimate conspiracy theory, something you wouldn't expect in the 21st century. In fact, it's something that you wouldn't expect in any century for at least the last 2,000 years. It's the belief that the Earth is flat. It's not spherical, but totally flat and circular, with the North Pole in the middle, and the South Pole goes around the edges with high ice walls surrounding it. We are told that the moon landing is fake. All the photographs ever taken of the Earth is photoshopped. Every pilot, government, whether it's of a country or a tiny village, whether they are enemies or friends, they're all united with this one thing: to hide the real shape of the Earth. Those who believe this tell us that the flat Earth is kept secret by the military, the space agencies, NASA, all shipping companies, all airlines, including transnational companies that move goods around the world, odometer manufacturers, the navigation industry, every astronomer, whether amateur or professional, physicists, satellite TV providers, and every employee of all these companies are all involved in this global conspiracy, not just for now, but for as long as these industries have existed. This is no joke.
This globe model is very important for the elite. The satanic elite, may I say, because this globe model is being used to lure us away from our spiritual beings.
There is even a Flat Earth Society set up specially to promote this belief and to try to come up with every single explanation to support the idea that the Earth is flat. On top of all that, there are now celebrities joining in, like Bobby Ray Simmons Jr., known as B.O.B., and Tilly Tequila, and many celebrities. According to the survey done by YouGov in April 2018, 2% of Americans absolutely believe that the Earth is flat. That's over 6.5 million people who believe the Earth is flat. Not only that, but at least 5% of the public say that they used to believe that the world is spherical, but now have doubts. That's about 16.5 million people beginning to think the Earth could be flat. And this survey says that most of the Americans who believe the Earth is flat are millennials. And on top of that, most say they are religious because it's written in their scripture. For some reason, it looks like there is some link between being very religious and accepting the flat Earth conspiracy. But what about the British? What's the view in the UK? Surely the British don't believe the Earth is flat, do they? Well, in a survey made a year later by the same organization, YouGov, in 2019, they found that 1% of Britons say that the Earth is definitely flat. That means more than 500,000 people of the British population believe that the Earth is definitely flat. Over 1.3 million believe the Earth could be flat, and over 2.5 million people don't actually know. That's huge. Now, in case you're interested, none of the British younger generations actually say the Earth is definitely flat, but they are more likely to say that they don't know if the Earth is flat than the older generations. But why would anyone want to hide the shape of the Earth? If you ask, they say, well, the whole flat Earth secrecy is to hide the fact that God exists, or it's because people want to make money. But I'm not sure how this would help people to make money, because to me, it sounds like it would cost a lot more money to hide something like this than making money keeping it hidden. Also, if people are trying to hide God, it's probably easier and less work to go out and find every single manuscript that ever existed and destroy it. I think that might be easier to do than to keep hiding the shape of the Earth from everyone for all time. So, how would you go about finding out for yourself if the Earth is flat or not?
If I go to the seashore, I was always told, if I go to the seashore, oh, look at that ship going over the horizon. Going over the curve. Yeah, that's what I was told. You get a pair of binoculars out, and you'll bring that ship back into view. And when it goes out of sight again, get a telescope out, and you'll bring it back into view.
This is why we are here today on the shores of Skegness. Here you can see about 129 turbines just off the Skegness coast. We're told that combined, they can produce enough energy to power more than 330,000 homes. And on the shores of Chapel St. Leonard's, here you see what they call Racebank Wind Farm. 91 turbines placed in the sea that covers an area bigger than 10,500 football pitches, creating enough electricity to power up 500,000 homes. Each turbine is 100 meters high above the sea level, and they are about 28 to 36 kilometers away from the shore. What's interesting is that each turbine has a yellow platform about 15 meters high from the bottom up, which is just perfect because that's going to help us decide if the Earth is curved or flat. If the Earth is curved, then 28 kilometers should give us a drop of about 61 meters. If it's 36 kilometers away, that should give us a drop of about 101 meters. That means we shouldn't see any of the turbine at all. Well, we'll ignore the height of the blades for now. Having said that, we won't be standing at sea level, of course, because our cameras will be on top of a tripod standing on the ground, which will also be a little above sea level. That means we will probably be between 1.5 and 5.5 meters above sea level. And at that height, we should be able to see at least the top third of the turbine, even of the ones that are furthest away. So all we have to do to know if the Earth is flat or curved is to look at the turbine and watch out for the bottom 15 meters yellow platform. If we can only see the top without seeing the bottom yellow platform, then the Earth has to be curved. If we see the whole 100-meter turbine, but of course just smaller, then the Earth is flat. Is that fair? Now, the nice thing about this test is that anyone can come and do this test for themselves any time of the year, as long as they make sure that they have good visibility. Let's give it a go and see what happens. The closest wind farm you can see from here is known as the Links Offshore Wind Farm. These are about 6 to 11 kilometers away. As we pan to the left, we begin to see turbines behind the Links Offshore Wind Farm. These are part of another wind farm called Racebank. These turbines are much further away. They are between 30 and 35 kilometers away. If we do the math with the curvature of the Earth, we calculate that we should only see the top 2/3 of the closest turbines. And that's exactly what we see. The yellow platform is missing for each and every one of them. That's the bottom 15 meters of each turbine. The fact that the base is not visible tells us that the Earth is curved. This is an observable, testable, and repeatable experiment that can be done by anyone at any location that has turbines built with these specifications. Now, I know you're going to call that something to do the refraction of light and things like that, but you wouldn't get it every single day of the year because that depends on temperature of the environment, temperature of the sea, temperature of the atmosphere.
Theory. What's a theory? Theory, an idea. It's like the theory of gravity. It's only an idea. Cannot be proven.
What is gravity? Well, according to NASA, it's this invisible force that pulls objects toward each other. It's why things fall down. It's why we can walk on the ground and not float into space. It's why we can play games, kick a ball, and see it come straight back down again. It's really very useful. It's what keeps our moon, planets, and sun in orbit. So anything that has mass has gravity. And of course, the strength of this gravity depends on the mass. It's gravity that makes things have a weight. If you have less mass, there'll be less pull. If there is less pull, then that thing is going to weigh less. Those who believe in flat Earth reject Earth's gravity. They say, it doesn't exist. But why reject gravity? They have good reasons for it. Because if gravity exists, then that causes problems for the flat Earth model. First of all, if you have enough time, this flat shape will soon crunch down to the shape of a ball. This ball shape is exactly what they're trying to avoid. But the problem gets worse. On globe Earth, gravity pulls in all directions the same way. So on globe Earth, since it's a globe, no matter where you stand, it wouldn't matter because you'll always stand upright. But gravity would behave totally differently on a flat Earth. Since gravity pulls everything to its center on the flat surface, it means you can only stand upright in the middle. Well, that's basically the North Pole. When you run towards the edges, we pull back to the middle where the center of gravity is. So if you try to run to the edge of a flat Earth, it'll be like running uphill to the top of a mountain. That means people in South America and South Africa and Australia and, well, people everywhere, other than the center of flat Earth, would not be able to stand upright. Not just people, trees would also have the same problem. Instead of growing upright, they'll grow leaning sideways, just as they do growing on the side of a mountain. On top of that, on flat Earth, the rain will always fall towards the middle, and the seas will collect towards the center of the Earth's gravity, just as they would running downhill to a valley, leaving the edges dry like deserts. Any kind of sports game would be a nightmare. It's like playing on a hill. Every time you kick that ball, it comes straight back to the center of the Earth. The closer you are to the edge, the stronger the pull. It'll be like playing a ball game on a slope or a steep mountain. So to solve this problem, the flat earther must replace this gravitational pull with something else. Some say, well, it's all to do with buoyancy and density.
That falls down to the ground because the molecular structure of that is denser than the molecular structure surrounding it. So hence it will fall. This is why maybe a balloon rises, because helium is lighter than air, so a balloon rises. Happens in water. Drop a brick in water, it will sink. Drop cork in water, it will float. Take yourself to a cliff at the seaside. Jump off the cliff, you'll say gravity's pulling you down. But once you hit the water, you stop because the water is denser than you are. So that's all that is, buoyancy and density.
In simple terms, things that are heavier than air go down, and things that are lighter than air, well, they go up. A feather goes down because it's more dense than air, so the air goes up and the feather comes down. A balloon filled with helium goes up because it's less dense than air, so this time the air comes down and the balloon goes up. Simple. But the big question is, why down? The air is all around us. Why not up or sideways? It doesn't make sense. Also, the only reason the air goes down is because of gravity, making things go down or up. But with just buoyancy and density, this behavior wouldn't make sense. But we're going to ignore all that. We're going to pretend buoyancy and density is why things go down. They go down because air goes up, and because of that, the other heavier thing comes down. Got it. So let's do a quick test. This is what we call observable, repeatable, testable science. If it works, then it must be true. Here is a test done with air bubbles in a weightless environment. As you can see, the bubbles don't go up or down. They just stay and hover inside the bubble of water. If it's all to do with buoyancy and density, shouldn't the bubbles go up as they are lighter and less dense than water? Here's another test that could help, but this one you can do at home. If the reason why objects go down is because they are more dense than air, then all we have to do is to get a small object like a feather and put it in an airtight chamber, take out all the air and see what happens. If it falls down anyway, then the air buoyancy and density have nothing to do with why things fall down. If you don't have something like this, don't worry. There are companies that would hire out machines like these, which is what we've done. We put a feather inside this machine and took all the air out. Our normal atmospheric pressure is just over 1000 millibars. After a few minutes of running this machine, we get a vacuum of less than 1 millibar. Actually, it can go as far as 1/10 of 1 millibar. Now that's impressive. We put a fan inside this machine so you can see when all the air is taken out, the feather stops moving. Once all the air is out, we're ready for the experiment. So if I brought in a chamber, say a big chamber or a room, and take all the air out, so it becomes vacuum, there is absolutely nothing there, and I put, say, a feather in this chamber,
Yes.
but there is no air, so there's no density of buoyancy with the air, what would happen to the feather? Would it float or go upwards, or what would happen?
You tell me. You're the one.
Yeah, but
on
what
the
would-
vacuum thing.
Yeah,
I mean,
what do you expect to happen if to the air? If air is causing
wouldn't
things
it just
float in space?
go wander about aimlessly in the chamber?
It will aimlessly wander in the chamber. That's what you would think. Yeah. But that would be the obvious conclusion to come to if air.
Because if there's no, it can't drop.
Yeah.
It's not going to rise. So if it's vacuum,
The feather would move around kind of weightlessly, effectively. Yeah.
yeah.
If the buoyancy and density of air is the reason why the feather falls down, then the feather should now not fall down at all in this chamber. If on the other hand gravity exists, then the feather should still fall down anyway. In fact, it should fall down even faster because there is no air resistance. Let's have a look. There you have it. Buoyancy and density have nothing to do with why things fall down. It has to be gravity. What if it came down? How would you feel about that?
What if it came down in the
Flat.
vacuum?
It's so fast, faster than if it was in real air because there is no friction. Would you be surprised?
Well, again, it's a thing I'd have to look into regarding a vacuum and how a vacuum actually operates as such.
But of course, not all flat earthers believe that the buoyancy and density is the real reason for why things fall down. Another view is that the Earth is flying through space in the upward motion. They call this the universal acceleration. They say that's why things fall down at 9.8 meters per second squared. It's because the Earth is accelerating upwards at 9.8 meters per second squared. It's based on something Einstein said. He even gave it a name. It's called the equivalence principle. It's the idea that if you're accelerating upwards at 9.8 meters per second square, you wouldn't be able to tell the difference between the effect this has on you, pulling you down, and the effect that gravity has on you, pulling you down. But Einstein specifically said it's locally indistinguishable. What does that mean? It means you can't tell the difference in a small area, but you can distinguish between them if you're measuring over a big area. So if you are in an elevator, you won't be able to tell the difference between the elevator going up and gravity pulling you down. In fact, this is what caused Einstein to springboard from special relativity to general relativity. So how can you measure this difference over a big area? Well, you don't have to go very far and you don't have to have very sensitive tools. If the Earth is accelerating upwards, then our weight should be the same everywhere we go. If not, then it will vary depending on where we are. That's because gravity is weaker the higher you go and is also affected by mass. It turns out when we measure the same weight from different places, we do get different results. It depends on whether we're standing on the top of a mountain or bottom of the valley, depending on whether we're at the north or south poles or the equator. It even depends on whether the ground beneath us has granite rocks or pumice volcanic rock. So obviously the gravity pull does change depending on where we are. That wouldn't happen if the universal acceleration model were true. It just wouldn't happen if the Earth is accelerating upwards at a fixed 9.8 meters per second squared. It would instead be all the same. If the Earth were accelerating at this constant speed, this force will also apply to the Sun, Moon, and stars because we're told they are supposedly inside this dome. So what's keeping them from falling to Earth? Are they also accelerating upwards at the same speed? Or are they hung or stuck on something? And if so, shouldn't this constant force eventually win and make them all fall on Earth? But what's strange with this idea is that flat earthers strongly believe in geocentrism, which is the idea that the Earth is supposedly a fixed object, firmly established and doesn't move, and that the Sun, Moon, and stars and everything else orbit around the Earth. If flat earthers don't have a problem with the Earth continually accelerating in an upward motion at 9.8 meters per second squared, which incidentally will eventually have to come close to the speed of light, then why have a problem with the Earth revolving around the Sun at a much lesser and more reasonable speed? Wouldn't that make more sense? Either way, the Earth is moving, right? Now, in case you're interested, to accelerate an object that weighs just 1 ton to 10% of the speed of light, it will need 450 petajoules of energy. To work this out properly, we're told the Earth is 5.9 trillion billion tons, but flat Earth is of course a lot smaller, so we'll assume it's not half, not even a quarter of globe Earth. To make sure we're as fair as possible, I'm going to assume flat Earth is only about 1/6 of that mass. That means to get flat Earth to travel at just 10% of the speed of light, we need the equivalent energy of more than 36 billion atomic bombs. That's a lot of bombs. I mean a lot. And that's just for the first few months. I'm sure the Earth has been around for longer than a few months. But it gets even worse. As it gets faster and faster, getting closer and closer to the speed of light, it will need more and more energy. If the Earth ever did reach the speed of light, Einstein's theory of relativity tells us we would need an infinite amount of energy. Do you know how much infinite amount of energy is? Well, it's a lot. Now, does the Earth have that kind of unlimited energy stored somewhere to help it accelerate at that ridiculous speed indefinitely? Unlikely. Even if it did, what kind of heat would that generate? I'm afraid it gets much worse than that. The energy we're talking about well, it better not be coming from some mysterious dust particle in space. Because even if there is the smallest, tiniest dust particle in space and it hits our dome at only 10% of the speed of light, it would cause an unimaginable explosion. This explosion would be the size of 10 tons of TNT explosives. So this dome that's above us better be made of some very special super material. Not only that, but the universe better be super squeaky clean too. Because if not, by the time the Earth starts traveling at 50% of the speed of light and hits something as small as a pea, well, it's going to be a problem. It will produce a humongous explosion. This explosion will produce a kinetic energy the size of 2.2 atomic bombs. Imagine the heat this can produce. How is this dome going to cope? So this dome better be super tough, super aerodynamic, super heat resistant, super extraordinary, and just super. Guys, we can't reconcile the physics of flat Earth with the science that we know and understand very well. It just doesn't work. So if this downward pull has nothing to do with buoyancy and density, and the Earth is not accelerating upwards at 9.8 meters per second squared, then it must be gravity. But what is gravity? And how can you show that there is some kind of force that draws objects together toward their center? Is there an experiment we can do to see this with our own eyes? Yes, and guess what? You can do this yourself at home. This experiment goes back more than 220 years ago, in the 18th century by a clever guy called Henry Cavendish. Actually, this experiment goes back before him, but he was the one who finished calculating all the figures. Now, he was not trying to prove that gravity exists between two objects that have mass, because that was already taken care of before that time. Henry Cavendish was trying to calculate the mass of the Earth and its density, and he did a very good job. Later, other scientists used this to calculate the gravitational constant, big G. He basically took a wooden rod, put two small weights on either side of it, and balanced this rod on a wire. He then took two large weights and put each one about 9 inches away from the small weights. If you try this at home, after letting everything settle for a few hours, you'll find that the rod will start oscillating clockwise and anti-clockwise at a certain pace. And that pace and distance change as soon as you add these two large weights next to them. When the gravitational constant big G was calculated again in 2014, it was within 1% of the figures that Cavendish came up with. That's 1% accuracy using basic primitive tools. Now, that's not bad at all. Well, I thought I'll repeat the experiment myself and see what happens. And that's exactly what I did in my house, in my garage. I took a wooden rod about 1 meter long, put a 3-kilogram weight on each side, I let things settle for a while, and then I did a time-lapse recording for at least 12 hours. This was around 240 times faster than normal time. Once it appeared to be oscillating at a steady pace, I put the large weights at each end close to where the oscillation is happening to see if it makes any difference. Lo and behold, as you can see, the oscillation has been affected. These two smaller weights seem obviously pulling towards the larger weights. The center of oscillation would also shift closer to them. Of course, my goal was not to calculate the Earth's mass like Cavendish did, or to try to work out the gravitational constant. I just wanted to see if there was going to be any kind of pull between two objects with a reasonable mass we call gravity. And there obviously is. And just in case you were wondering, the rod was made of wood and the weights at each end were made of plastic filled with sand. The larger weights around the edges were made of metal put on concrete. So there couldn't have been any magnetic or static forces interfering between these parts. Certainly not like this. Now, if you're still claiming as flat earthers do and say, well, maybe something else caused this pull between these objects, like air, temperature, light, anything, but still not gravity. Well, you'll find that this experiment would still produce the same result even in a dark vacuum chamber after removing all these variables. That's because gravity is a real thing that truly pulls two objects towards each other, depending on their mass and distance. You can even manipulate this gravitational pull by changing the mass of the object. This is how you can experiment in your own home and do tests that you can repeat, demonstrate, and see for yourself. So it's kind of like a dome. That's what we're at the moment.
Yeah.
And then if you stand here, you see a completely different set of stars versus when you stand.
Northern, southern, yeah.
Yeah.
It's the way where you're situated. Yeah.
Tell me something else. Why is it people in the southern hemisphere see the stars moving in a different direction, like clockwise in the southern and anti-clockwise in the northern hemisphere, which will fit with the Earth being a sphere? Down below, they see a different.
Well, I don't know about.
You've not seen that before?
No, not that.
Flat earthers tell us that there is a spherical shaped dome above the Earth and that the sun, the moon, and all the stars are rotating inside this dome. The sun and moon are about 32 miles in diameter and only about 3,000 miles away. Some say that the stars are only about 100 miles above the sun and moon. If all the stars are rotating in and with this dome, then how come when we look up at the sky from the North Pole, the stars appear to be rotating anti-clockwise? But from the South Pole, they rotate clockwise? If the flat Earth model is correct, shouldn't they all rotate in the same direction? It gets worse. If you go to the equator and look up, the stars appear to be moving in 3 different directions at the same time. If you look towards the southern hemisphere, they rotate clockwise. If you look towards the northern hemisphere, they rotate anti-clockwise. And looking directly above you, the stars appear to be going in a straight line. Only a globe Earth can properly explain this behavior. Also, when we're near the South Pole looking up, we see a completely different set of stars than the ones we can see at the North Pole. If the Earth is flat, shouldn't we be able to see all the stars from anywhere since they're all directly above and all around us in this dome? We should at least be able to see the northern stars from anywhere because the North Pole should be visible from any location on flat Earth. But that's not what we see, which is consistent with the globe Earth. And finally, if the Earth is flat and the stars are rotating around the dome, then the only place where the stars are rotating in a circle would be directly above the North Pole. That's because when looking at the northern stars from anywhere else, the stars would appear to be turning in an elliptical orbit. But that's not what we see. Doing these tests are easy. You don't even have to physically travel anywhere. You just need to know someone who lives around these parts of the world and ask them to send you a time-lapse video of the sky pointing towards the northern or the southern hemisphere. Sending information like this these days is not a difficult thing to do. You know what's interesting? If you did go to Australia and look at the sky, because you're nearer down to the edge of the dome, aren't you? You're not all the way, you're nearer. You should be able to look sideways and look at the stars moving sideways like that, because as far as the dome is concerned, everything is turning inside it, right? So you should be able to see it inside.
Well, they go all ways when you see stars.
Well, I mean, it's like this when you're at the North Pole. It's like this when you're in the North Pole, isn't it? So it keeps going like that because when you go around the edges, like you're in England and you go further down to Africa, you start seeing it. You see you see everything is surrounding that, and then when you're looking further down, that's when you're getting closer to the edge. You should see the stars going that way, but they don't see that. What do you think? Why do you think that's the case?
I don't know why that is then. It's something we'd have to look into. Being not told, there's something there, you see. But these people, they don't want us knowing anything. They don't want us knowing anything. The less we know, we're slaves. We're only being told what they want us to know and keep us, cause division, so we'll never get anywhere with it.
I mean, how would it affect you if it turns out the Earth is not flat? How would you feel?
I can't see it being in any other way. I can't see it being. There's no other way. There's no other way. There's no other way. I can't go back to the globe, mate, because I can't. I can see it. I can see it. I can see it. This is the thing. You've got to see it with your own eyes.